So now let's make use of that intermediate value theorem with the following example. We're going to show that the function f of x equals x cubed plus x minus 4 has a root somewhere on the interval from 1 to 2. Now, we are going to use a graphing calculator to supplement this, so if you don't already have it out, go ahead and pause the video and grab your graphing calculator. So first thing to note is that f is a polynomial function. Which is continuous on its entire domain. Domain of a polynomial function is all real numbers. So first part of the intermediate value theorem is to show that the function is continuous on the given interval. Well, the given interval is from 1 to 2, and 1 to 2 is definitely within all real numbers. So with that in mind, according to the intermediate value theorem, if we can show that f of 1 and f of 2 have opposite signs, then we can draw the conclusion of the mean value theorem and say that it definitely has to cross the horizontal line y equals 0. So f of 1 would be equal to 1 cubed plus 1 minus 4. That'd be negative 2. Most important part of that is it is negative. Then when we plug in 2, we'll get 2 cubed plus 2 minus 4, which is 8 plus 2, which is 10, minus 4, which is 6, which is positive. So essentially what we have just done is we have shown that this cubic polynomial function, x equals 1, x equals 2, has a y value at at positive 1 of negative 2, and then at positive 2 we get a y value of positive 6. According to the intermediate value theorem, we can select any value of y between negative 2 and negative 6, and this continuous function must cross it. Well, if we pick the value y equals 0, because it's a continuous function, we know that somewhere in here it's guaranteed to cross the x-axis. And that'll give us an x-intercept. An x-intercept is also known as a root when it comes to a polynomial function. Now, if you were interested in finding this root with a little bit more precision, your graphing calculator is capable of doing so. So let's talk about how to use the graphing calculator to find that root more precisely. So in the y equals menu, oh boy, yeah, I remember that experiment. That was pretty terrible. Let's go ahead and graph x cubed, so x to the power of 3, plus x minus 4. Now we need to set an appropriately sized window for this. For the x direction, we're looking between x equals 1 and x equals 2. And based on our calculations, we know that y is going to be between negative 2 and positive 6. So if I take a look at the graph, we should be able to see, no problem, where our x-intercept is. Doesn't look exactly like mine, and that's fine. I am no artist. Now, the tool that you're going to want to make use of is found in the Calculate menu. That's second, followed by Trace. You're looking for a 0, or a root. That would be option 2. The calculator is going to then request 3 things from you. The first one is known as a left bound. So you can see that our x-intercept is right about here. The calculator doesn't necessarily know that it's going to be right there, and we have to kind of point its focus toward that point. So by left bound, we're saying don't look any farther left than this point. So just take your cursor, put it ever so slightly to the left of the x-intercept and press enter. Then it'll ask you for a right bound, so we'll repeat the process, this time going to the right side of the x-intercept. Press enter again. How far to the left and right you go doesn't really matter, we just want to make it very obvious that our x-intercept is within the given interval. Then for a guess, we put our cursor right about on top of the x-intercept, and the calculator will give us what that x-intercept is with usually about 6 or 7 decimal places of accuracy. Now, back when calculus was being developed all of those centuries ago, unfortunately they didn't have access to the TI-84 plus CE graphing calculator, so they had to kind of eyeball these things for themselves. Those poor guys. All right, well, hopefully this helps give you a bit of a better understanding of the intermediate value theorem and using your graphing calculator.